2,000 feet of solid granite sits above them. In front of them is a door that weighs 25 tons, 3 feet thick, that can seal in about the time it takes to read this sentence. And underneath them, holding up the building they are standing in, are more than 1,300 steel springs, each one about the weight of a small car. That last detail is the one that stops people, not the granite, not the door, the springs, because the mountain, the thing everyone pictures as the protection, is not actually what would keep the crew alive if the worst arrived. The mountain is just rock, and rock transmits a shock straight through itself. What keeps the people alive is that the buildings they work in are not attached to the mountain at all. They hang, they float on those springs inside a hollowed-out cavern, deliberately disconnected from the stone around them, so that when the ground heaves, the buildings are allowed to move and the people inside them are not thrown against the walls. A crew stands watch in there, around the clock, every hour of every day, sealed inside a machine built to be the last working part of a country after everything above it is gone. And the strangest thing about it is how much of that survival comes down not to the rock, but to letting the building move. How that works, and the night a coin's worth of hardware nearly undid all of it, is what this is about. Here is the assumption almost everyone carries, and it is wrong in a way that turns the whole design inside out. People hear bunker inside a mountain and picture safety as thickness. The deeper you go, the more rock over your head, the safer you must be. And the depth is real. 2,000 feet of granite is not nothing. But depth alone does not save you, because a shock wave does not politely stop at the rock. It travels through it. A large enough blast at the surface sends a pressure pulse down through solid stone, and the stone moves, and anything rigidly bolted to that stone moves with it, violently. If the command center were simply built onto the floor of the cavern, the crew inside would be subjected to the full shock of the mountain flexing, and no amount of granite overhead would help them. So the engineers did something that sounds almost backwards. Having buried the facility as deep as they could, they then went to enormous lengths to disconnect it from the very mountain that protects it. That is the central idea, and once you see it, the whole complex reads differently. There are 4 things worth understanding to see how a place like this survives. How the buildings are decoupled from the rock so a shock cannot reach the people. How the entrance is shaped and sealed so a blast has nowhere to go. How the air and water and power are made completely independent of the outside world. And how a crew lives and stays sharp inside it for a shift that never really ends. 4 systems, and behind all of them, one crew who has to decide whether what the screen is telling them is real. We will take the complex as it has stood since the height of the Cold War, built in the 1960s and running continuously ever since, and every figure here is drawn from the published and declassified record. If this is the kind of thing you would give an hour to, the channel exists for exactly this, so consider subscribing before we go inside the mountain. We start with the danger, because the danger is not what most people think it is. Understand what a nearby blast actually does to a buried structure, because it is not what the films show. The threat to something 2,000 feet down is not fire, and it is not the flash. Those stay at the surface. The threat is ground shock, the pulse of energy that a large surface detonation drives down into the earth, and the way it moves is the whole problem. Solid granite is an excellent conductor of that kind of shock. It does not absorb the blow and cushion it. It passes it along, the way a struck rail rings down its length, and a structure fixed to that granite feels the mountain lurch beneath it in a fraction of a second. The displacement can be sudden and it can be large, and a rigid building attached to a moving floor does not survive that intact. Racks tip. Equipment tears from its mounts. People are thrown. The mountain, in other words, is both the shield and the delivery system for the thing that would do the harm. And this is the part the intuition gets wrong. Going deeper buys you protection from the surface effects, the heat and the immediate overpressure, but it does not buy you protection from the ground moving. If anything, it puts you more firmly in contact with the rock that carries the shock. So the number that reframes the whole design is not the depth, it is the distance the buildings are allowed to move. The structures inside the cavern are engineered to shift by up to about a foot, a full 12 inches in response to a shock or a seismic event, and to do it without transmitting that movement to the people and equipment inside. That figure, a foot of permitted motion, is the entire survival concept expressed as a single measurement. The design is not trying to hold the building perfectly still. Holding it still is impossible when the mountain moves. The design is trying to let the building move freely enough that it is never jerked, only carried. Think of a passenger on a ship in a swell. Bolt a chair rigidly to the deck, and the person in it is slammed as the hull rolls. Let the chair swing on a gimbal, and the deck can heave while the seat stays level. The command center is built to swing on a gimbal, and the gimbal is made of steel springs. So here's the inversion, the single fact that most people never hear about this place, and is almost the opposite of what the word bunker suggests. The 15 buildings inside Cheyenne Mountain do not rest on the floor of the cavern. They stand on more than 1,300 enormous steel springs, each weighing roughly 1,000 pounds, and the entire complex is suspended on them, floating clear of the granite. The buildings are not part of the mountain. They are hung inside it, decoupled, so that the rock can take a blow and shift, and the springs absorb and slow that movement before it ever reaches the structures they carry. The mountain moves. The springs stretch and compress. The buildings ride it out. That is the mechanism, and the reason it is springs and not something more exotic is worth understanding, because it is the same logic that runs through this entire complex. A spring is simple, passive, and needs no power and no command to do its job. It does not have to be switched on. It does not have to be told a shock has arrived. It simply is what it is all the time, and it responds to a load the instant that load appears, faster than any sensor could detect the event and any system could react. The protection is built into the physics of the arrangement, not into a device that has to work correctly at the worst possible moment. And notice why the limit sits where it does. The buildings are allowed a foot of movement, not because a foot is the most they might ever need, but because the springs are tuned to keep the structures inside a range where the equipment keeps running and the people keep functioning, with margin beyond that before anything is actually endangered. The design is not aiming to keep the crew barely alive through a maximum event. It is aiming to keep the command center operating, keep the screens lit and the crew working through a shock that would flatten anything on the surface. That is a far higher standard than survival. It is continuity, and the flexible connections between buildings, the corridors and the pipes and the cabling are all built to accommodate that same foot of movement, flexing rather than snapping, so that a facility that has just been shaken still has power and water and air running between its parts. Which raises the next question, because a floating building is only as sealed as the way in, and the way in is a problem all its own. Look at how you actually get into the complex, and every part of it is a decision about where a blast is allowed to go. The approach is not a straight shot to a door. It runs through a tunnel bored into the north face of the mountain, and the tunnel is shaped like a J, curving as it goes. That curve is not for the road. It is a blast feature. If a detonation occurs at the mouth of the tunnel, the overpressure wants to travel straight, and the bend gives it somewhere to continue straight into, past the turn, rather than around the corner and into the complex. The shape of the passage lets the pressure blow through and out again, while the entrance to the actual facility sits off to the side, shielded by the geometry. Then come the doors. At the inner end of the approach sit 2 blast doors, each weighing about 25 tons, 3 feet thick, and they are the boundary between the outside world and the sealed volume. They can be closed by built-in hydraulic machinery in well under a minute, and here is the detail that tells you how the design thinks. If the hydraulics fail, the doors can be closed by hand. 2 people can crank 25 tons of steel shut with muscle, because a door that only closes when the power is working is not a door you can trust at the moment you most need it. When those doors seal, the interior becomes its own isolated volume. Now the structure around all of this. The cavern was carved out of solid granite, and the rock itself is the outer armor, but the working spaces are the 15 freestanding steel buildings inside it, and the crucial thing is what separates them from the stone. Between the buildings and the rock is deliberate empty space, and the spring mounts so that the two are never in rigid contact. The rock stops what comes from outside. The gap and the springs stop the rock's own movement from reaching the crew. It is the same 2-layer logic as any well-designed protective structure. An outer shell that takes the hit and an inner arrangement that isolates the people from the shell. Except that here, the outer shell is half a mountain. And the springs themselves are worth a closer look, because there are more than 1,300 of them, and they are not arranged casually. They sit between the base of each building and the cavern floor, mounted so that the load of the structure is spread across many of them at once, no single spring carrying more than its share, and so that the building can move in more than one direction, settling and swaying rather than only bouncing straight down. A structure that could only move vertically would still be slammed by a shock that arrived sideways, and ground shock does not politely arrive from one direction. The mounts are built to give in whatever direction the mountain pushes. It is a mundane piece of mechanical engineering, coil springs and steel mounts, the same principle as the suspension under any heavy vehicle, applied at a scale and for a purpose that turns something ordinary into the thing the whole complex depends on. And the doors have a second function beyond blast. Once sealed, they do not only hold back overpressure, they close the interior off into an airtight volume, which is what makes it possible to control the atmosphere inside at all, to keep the outside air, and anything carried in it, from ever getting in. That seal is the reason the next system can exist, because a place that can be closed off completely is a place that has to make everything it needs, which is exactly what it does. Here is where the obvious threat turns out to be the wrong one to plan for. Ask what a place like this has to survive, and the mind goes to the blast, the shock, the door slamming shut. But the blast is over in seconds. The real problem begins the moment the doors are sealed, because now the crew is cut off from the outside world entirely, and everything a human being needs to stay alive has to already be inside, or has to be made inside for as long as the isolation lasts. This is the part that makes it a machine for living rather than just a shelter. The complex is built to run sealed off, self-sufficient, for an extended period, and every essential is either stored or generated within the rock. Water is held in vast reservoirs carved directly into the granite, millions of gallons of it, pooled in the stone itself. Fuel for the generators is stored in enormous quantity, hundreds of thousands of gallons, enough to keep the power plant running without a single connection to the grid outside. And the air, the thing that matters most, is drawn through layered filtration built to strip out radioactive fallout and chemical and biological contaminants before it ever reaches the crew. When the doors are open, the complex breathes filtered outside air. When the doors seal, it closes into its own atmosphere and manages it internally. Now walk that independence from the sophisticated layer down to the crude, because the pattern is the same one we keep meeting. At the top is the full system running normally. Outside power, outside air, everything flowing. Below that, the complex switches to its own generators, burning its own stored fuel, breathing its own filtered and recirculated air, needing nothing from the surface. And below even that, the simplest layer of all, the sheer stored quantity, the water and the rock and the fuel in the tanks, which require no clever system to work, only to have been put there in advance. The most sophisticated protection depends on machinery running. The crudest depends only on someone having filled the reservoirs. And here the second function appears again, quietly. The independence was built so the complex could survive being sealed off in an attack. But that same self-sufficiency is what lets it function as a stable, isolated, interference-proof command center every ordinary day, immune to a storm that takes down the regional power grid, immune to anything happening on the outside, a place where the screens stay lit no matter what. The system built for the worst day is the reason it is reliable on every ordinary one. And all of it, the springs, the doors, the reservoirs, the filtered air, exists to keep one thing running, which is the crew's ability to watch and to judge what they are watching, which is exactly what nearly failed. Not from a blast, but from a part that cost less than $1. It was the early morning of the 3rd of June, 1980, and nothing had happened. No attack, no crisis, an ordinary night inside the mountain. Then the screens at the command center lit up with a warning that 2,200 Soviet missiles were inbound. Not a handful, a full-scale attack. The response was immediate and exactly as drilled. Crews were alerted, bomber and missile forces were brought to readiness, the airborne command post was prepared. And remember the detail set down earlier, the one about the computers, the 427M system, and the plan to move testing onto a separate machine. This is where it matters, because 7 months before, in November of 1979, the mountain had already been through one of these. That time the screens had shown a Soviet submarine attack, interceptors were scrambled, and it was traced to a test scenario, a war game tape, that had found its way into the live warning system during troubleshooting of that same problematic computer setup. The corrective action after 1979 had been precisely to separate the testing from the operational system, so a simulation could never again leak into the live picture. And then June of 1980 happened anyway, and the cause was different, which is the whole point. This time, it was not a procedure. It was hardware. A single integrated circuit, a computer chip worth about 46 cents, had begun to fail, and as it failed, it was randomly inserting figures into the count of incoming missiles the warning system was reporting. The number the crew saw was being generated by a dying component, not by anything in the sky. Nothing in that chain was exotic. A cheap part wearing out, doing what worn parts do, feeding a false number into a system that people were trained to believe. What stopped it was not the machine. The warning was cross-checked against other sensors, against satellite and radar data that should have confirmed a launch of that scale and did not, and within minutes, it was clear the attack was not real. No one was harmed. The system that failed was a component, and the system that caught it was a crew following a procedure of confirmation before commitment. The change that came out of it was the honest, unglamorous kind, more redundancy, better testing of the hardware, a recognition written into the procedures that the warning display could be wrong and had to be verified against independent sources before anyone acted on it. The lesson was not that the technology was fragile. The lesson was that the last check had to be a human being, refusing to treat a number on a screen as the truth until something independent agreed with it. Which leaves the part of the whole complex that was never engineered, because it could not be. Everything we have described, the springs, the doors, the reservoirs, the filtration, does exactly what it was built to do, and not one thing more. None of it decides anything. The springs do not know whether the shock is real. The doors close on command or on a hand crank and ask no questions. And the warning system, as June of 1980 proved, will report 2,000 missiles as readily as 2 because it is counting, not judging. So, the design does something that runs through this entire subject. Wherever a response can be made automatic and passive, it is, because a spring never forgets and a stored reservoir never fails to be full. But the judgments, the decisions, with minutes in them rather than milliseconds, are deliberately left to people, because no system in the mountain can be trusted to know whether the end of the world is actually beginning or a chip has simply died. So a crew stands watch, continuously, in a place with no windows and no day and no night, only the same filtered air and the same glow of the screens, hour after hour, on a rotation that never stops, because the mission never stops. That environment does its own slow work on people. The absence of weather, the absence of the sky, the sameness of every shift, and the design accepts that and builds around it, which is part of why so much was made automatic in the first place, to take the tiring, distractible human out of every loop where a machine could be trusted instead. But it could not be taken out of the last loop. The honest pattern, the one both false alarms show, is that the danger to a place like this was never really an attack at all. It was a training tape in the wrong slot and a 46-cent chip wearing out, ordinary failures inside its own systems, and the only thing standing between those failures and a catastrophe was a person trained to doubt the screen and check it against something else before they believed it. The panel displays. It does not conclude. The concluding is done by someone sitting a watch under 2,000 feet of rock, deciding whether what they are looking at is real. So count the 4 again, quickly, the way they actually stack. The buildings float on springs, decoupled from the mountain, so a shock passes through the rock and not through the people. The entrance is shaped and sealed so a blast blows past rather than in. The air and water and power are made entirely inside, so the sealed complex needs nothing from the world above. And a crew lives inside all of it, on a watch that never ends, to do the one thing the machinery cannot. 4 systems, and the 5th thing we named at the start now has a face. It is the watchstander who decides whether the warning is real. Go back to the image we opened with, the crew under 2,000 feet of granite, standing on more than 1,300 springs, in front of a 25-ton door. You can see it differently now. The mountain is not the thing keeping them alive. The mountain is just the rock that takes the hit. What keeps them alive and keeps them working is everything done to hold them apart from that rock and to make the sealed volume self-sufficient, and in the end, to leave the one decision that matters in human hands. The complex was built to be the last working part of the country after everything above it was gone. It has never had to be that. It came closest not to an attack, but to a coin's worth of failing hardware, and what saved it was a person who did not believe the screen. If you want to keep going inside places like this one, the ones almost no one is allowed near, that is the whole reason this channel exists, so subscribe and stay with it. The next one goes to the top of the world, into an early warning radar station on the Arctic line, where a small crew held a watch through a winter of total darkness, and the strangest part is what the cold did to the machines they depended on, and to the people. And a question for the comments while you sit with this one. If the greatest danger to the most protected place ever built turned out to be its own equipment failing, and not any attack from outside, then was all that granite and steel solving the right problem or the wrong one? There is a real argument on both sides, and I would like to read yours. This video is for educational purposes only. It draws on published engineering literature, declassified documentation, manufacturer and service publications, and investigated peacetime incident reports. Where a figure is an outside estimate or has never been released, this is stated, and where practice varies between services or jurisdictions, this is noted. Nothing in this video is operational guidance.